When emergency first responders were overwhelmed by Los Angeles County's most destructive fire yet, a band of surfers, along with their neighbors and friends, stepped up to defend their home turf in Malibu. Their devotion to home drove them to show up for their community during the fire and for years afterward. And now, a model they call the Community Brigade program could change everything, leading to more lives and more homes saved during the increasing wildfires across not just California, but the world. Join reporter Adriana Cargill from KCRW, NPR's All Things Considered, Crooked Media, and more, as she investigates a wildfire story that is not depressing, but is, in fact, a clear hope for the future. Listen now to Sandcastles, an award-winning podcast about home, how we create it, and why we fight so hard for it. Welcome to Important, Not Important. My name is Quinn, and this is science for people who give a shit, like you. Folks, there's a lot going on out there. Our world is changing every single day. We give you the tools you need to feel better and to fight for a better future for everyone. That includes the context straight from the smartest people on Earth and the action steps you can take to get involved. Our guests are scientists, doctors, nurses, journalists, farmers and educators, CEOs and founders, astronauts, even a couple reverends. Some quick housekeeping before we get to the episode. A reminder, you can send questions, thoughts, and feedback to us on Twitter at ImportantNotImp or on email at questions@importantnotimportant.com. That's also right there in your show notes. You can also join tens of thousands of other smart folks and subscribe to our free weekly newsletter at importantnotimportant.com. And that's the most important science news, plus analysis and action steps, once a week on Fridays. You can hunt for a new, impactful job on the front lines of the future at importantjobs.com. If you work for a company or organization already doing that kind of work, from climate change to maternal health to mosquitoes, you can list your open roles there for very affordable rates and get them in front of our entire incredible community, again, of scientists and designers and writers and product managers and engineers of hardware and software. All of them. We are so lucky to have them and excited to help them take that next step. Folks, this week's episode is going to help you understand the growing mosquito problem, which is really saying something when those little bastards have killed more people than basically anything ever. Our guest is the wonderful Dr. Omar Akbari, and he is one of the world's pre-eminent biotechnology and mosquito researchers. I learned so much about what's changing in the mosquito world, which now very much includes California, and that includes factors like climate change and also gene drives, which we talked about in one previous episode, and that has changed a little bit since then. We also talked about how a virus like SARS-CoV-2 or the disease COVID-19 could level up into something mosquitoes find hospitable. And then that's basically all she wrote. So please enjoy this episode. I hope you find something useful out of it. And again, send us feedback, and we'd love to hear it. Thanks. My guest today is Dr. Omar Akbari, and together we are going to, what's the best metaphor here? Take a bite out of the big mosquito question. How much of a problem are they globally? Shed some more light on that for everyone in the global north or Western world, and how is that changing for everyone? And how did we get lucky when it came to COVID, and what does that mean for the future? Dr. Akbari, welcome.
Thank you so much. I'm so happy to be here today.
For sure. Omar, if you could you tell us real quick who you are and what you do?
Yeah, my name is Omar Akbari, and I'm an associate professor at University of California, San Diego. I run a lab, and we do a lot of research on insect vectors, also on crop pests, and I also teach molecular biology at UCSD.
Wow. All right. So you got a few arrows in the quiver there, for sure.
Oh, yes. Yes, I do.
That's awesome. Well, we're glad you haven't settled for one boring topic and you're taking on all these. So thank you, sir. Dr. Akbari, we like to start with one kind of ridiculous question. It's a little tongue-in-cheek, but we feel like it does set the tone for things. Instead of saying tell us your entire life story, I'd like to ask, Doctor, why are you vital to the survival of the species? And I encourage you to be bold. Have fun with it.
Well, I would say that we are doing research which will benefit humanity. We work on mosquitoes, and mosquitoes are considered to be the world's deadliest animal. They kill more people on Earth than any other animal combined. There was actually an article that came out today in The Guardian that says, the climate crisis is going to put 8 billion people at risk of malaria and dengue fever. And that is going to be in 50 years from now. So the problem is not going away. It's getting worse progressively. And the tools that are presently available to combat this problem are not working, right? So I would say I'm here to benefit humanity by hopefully developing new tools to combat mosquitoes and other pests.
Wow. I did see that article, and our newsletter is about to go out today, and this is recording July 9th. And you see that number and you kind of blink and go, 8 billion? So basically everyone at that point? That's something else. That's something else.
Yeah.
Well, so before we get into all of that, I wanted to have this conversation today and kind of thinking about where we'll go with this. I mean, I'm sure you're aware through your work and to most folks out there, unless you have lived in Washington, D.C. and stuff like that, to most of the global north, as it's put, barring a Zika outbreak, mosquitoes can seem like very small potatoes. They're obnoxious, but they're not a threat necessarily to most folks in the Western world a lot of the times. But in the rest of the world, that's very much not the case. And it is getting more real here every day, like you said, with the dengue article there, which we'll definitely put in the show notes and talk about a little bit. So we need to be educated on not only what's coming our way and changing in places like Los Angeles and Southern California, where one of the biggest bragging rights has usually been like, no bugs, and that's changing quickly. But we also need to do a better job understanding how the rest of the world has been dealing with mosquitoes and the diseases they carry for a very long time. What has been learned there and what can be applied here, if anything, and what do the next 5-10 years look as we consider some of these newer technologies and efforts to reduce the sicknesses and the deaths in a lot of cases that are driven by mosquito travel. Does that make sense? Am I barking up the right tree?
Yeah, I think you're definitely barking up the right tree. Like you said, in the global north, there's not as much problem in terms of disease transmission by mosquitoes. We don't really have malaria transmission in the United States, for example, and dengue transmission happens occasionally, but it's not as significant as it is in other parts of the world. That said, there is some diseases that are transmitted in the United States, like West Nile virus and St. Louis encephalitis. And there was actually an article that came out, I think yesterday, that basically said there's 7 states now that have West Nile transmission happening within the United States. So there are definitely mosquitoes that are transmitting diseases in the United States currently, and the ones that transmit the very harmful diseases like dengue, Zika, chikungunya, yellow fever, they're here. They've recently invaded the United States. They're here. They've spread throughout California. They're in my backyard. Right, my kids get bit by them, and these are Aedes aegypti and Aedes albopictus. And so, right. While we don't have local transmission of dengue happening in California, right, that doesn't yet. Yeah. So, I mean, as people start traveling, right, again, post-COVID, it's possible they'll go to places where there is dengue. They could bring it back, right? And the mosquitoes are here. They'll bite them and then transmit locally. So it's just a matter of time, really.
Yeah. Well, I'm excited to help folks understand that context. I mean, that's one of the biggest things. As much as we try to drive action here, but like I mentioned to you offline, it's so important to have context for why we're doing it and why it's necessary in this moment, and what's changed to provide it, and what we can change by taking action. It's again, not to minimize something like COVID, which has obviously been horrendous and horrific in so many ways and to so many marginalized groups as it is. But it's the same reason we push big legislative and also NGO action and things like that on something like air pollution, which kills millions of people every year and is pretty easily fixable. It's a policy choice. Something like mosquitoes is obviously a little more complicated in a lot of ways, but like you said, it's happening and it's changing quickly. So we should talk about it. So one of the things that really stuck out to me in looking into this stuff again for sort of the second time and reading some stuff that you've been part of for a while, just for backstory, we didn't really have, everyone remembers, we didn't really have a great handle on how SARS-CoV-2 spread, the virus that leads to COVID. We all washed our hands and all of our groceries like crazy, and everybody was told not to do masks because theoretically the large droplets shouldn't have gotten through, and because we didn't have enough masks and the frontline health workers needed them. And then we all slowly came around to the fact that it's probably comes down to aerosols or airborne transmission. And so masks became, and we verified this incredible tool. But early on, you were quietly testing to make sure, sort of almost worst case scenario, that COVID wasn't being spread by mosquitoes like some of these other diseases you mentioned, like malaria and dengue in West Nile. I wonder, before you talk about that, did you do that testing because that's a sort of a standard practice when there's a novel virus or pathogen, or because there was a fear or even a possibility or probability that it was the case? Tell me how that works in your lab when you see something like that show up.
Great question. So just to clarify, our lab didn't actually do those tests to determine whether Zika was transmissible by mosquitoes. It was done by another group, but these mosquitoes that they're capable of transmitting viruses. They transmit many viruses, and so when you have a novel virus that comes on the radar, it's always good to see if these vectors could possibly transmit it, and that's what was done here. In particular, they tested whether Aedes aegypti and a few other vectors could transmit Zika, not Zika, I'm sorry, SARS-CoV-2, and they found that they could not. So I think it was a really great thing that the pandemic has been horrible and it still is horrible. We're still all dealing with it and suffering from it. So wearing a mask seems to work, right? Because majority of transmission happens through airborne droplets, right? So I mean, mask wearing really, really helps, and you can prevent spread that way. But you can't really. It's really difficult to prevent a mosquito from biting you. So if it was transmitted by mosquitoes, then just imagine what the quarantine would look like, right? People might be hiding in their bathrooms, to prevent, with masks to prevent both airborne droplet and mosquitoes from biting them. You wouldn't want to go outside, and these mosquitoes, a lot of them can bite during the day, and they live around our household in small containers. They breed in small containers, so they've sort of adapted to living in human habitats, and so they're really difficult to control. And so I think had it been the case, it would have been a much more severe situation.
So could you put any, obviously entirely hypothetical, but again, just so people understand, and talking with, and again, the diseases that the mosquitoes carry are obviously all different and in a variety of ways, and the SARS-CoV-2 virus is obviously different from those, but I guess putting it up against, and apologies if this doesn't make any sense whatsoever, but putting it up against what we know so far about the airborne aerosol transmission, how would the situation have been different? Not just practically hiding in our bathrooms, which, I mean, at that point, you got nowhere to go. You can't even open a window to get to get airflow, like we've learned is important. How would practically that have been different, I guess, possibly transmission-wise, if something like SARS-CoV-2 was carried by mosquitoes? What are we looking like, as that grows?
Yeah, I mean, it's really hard to put a number on that, but what I can,
for sure,
I
guess more scope.
Yeah, I mean, what I can say is that it just would depend on what species of mosquito is transmitting, and because different species prefer different climates. But I will say that it's estimated that 1/2 of the world is presently at risk of being infected by dengue virus, right? Because the mosquito is present in pretty much over half of the world. Half of the world, they live in areas that cover half of the world. So if the mosquitoes are present, right, and we all know that SARS-CoV-2 has basically spread everywhere, right, then you just would have this increased likelihood of transmission that would have been a result of mosquito bites. But again, thankfully, it wasn't the case. But what's going to happen? What is the next pandemic going to be? Right. The previous epidemic was Zika virus, right, and that was spread by mosquitoes, and we saw it was a scary time when you see these babies on the news that have microcephaly because of a mosquito-borne virus. So thankfully, that wasn't also airborne via droplets, but if it was, then that could have been far worse. So I think we need to figure out a way to deal with these mosquitoes, that is effective, that doesn't, rely on just spraying chemicals into the air that, are going to kill the mosquitoes, but also are going to kill other insects and
Sure.
possibly harm us as well,
Sure.
our kids. We need better solution. And the insecticides is, there's been documented resistance. Mosquitoes have evolved resistance to these insecticides. They're not as effective as they used to be. So we just need new solutions for when the next pandemic does happen. If it happens to be transmissible by mosquitoes, what are we going to do?
Sure. And if you could, again, if you could educate me and the rest of us, again, to try to understand some context, something like dengue or malaria or Zika, how often do those have sort of a variety of pathways of transmission? So not just airborne, but also surface, not just airborne, but also by mosquito. Is that something that's common, or would that be a pretty rare situation?
I think it would be a pretty rare situation. So all the pathogens that I've mentioned are vectored by mosquitoes, and mosquitoes are required for transmission. So it would be rare, but it's not out of the realm of possibility. So I think we just need to be prepared.
How, if you could go one step deeper with me, because I have a bunch of small children, all they do is ask why, and I'm trying to apply that in some of these bigger questions. How does a virus evolve to require a mosquito? Like, we know that viruses need a host, and with every host, it's a chance to either infect, make sick, or kill someone. But if it kills someone, it doesn't have anywhere to go unless it's gone somewhere else. But what is specific to those viruses and mosquitoes? Why mosquitoes?
Well, the viruses, they have hosts and they have vectors, right? And the host is oftentimes, an animal, or like us, for example, humans. And so, the virus is present in our blood. Mosquitoes need blood to propagate. So for mosquitoes to have progeny, female mosquitoes have to take a blood meal. And so it's an opportunity for the virus to enter the mosquito, right? And not all viruses are transmissible by mosquitoes. A lot of them, the mosquito immune system is able to sort of prevent the replication of those viruses, but some viruses are able to escape that, right? And these viruses, like dengue virus and Zika virus, for example, are really not predicted to harm the mosquito in any negative way, right? So they make it into the mosquito through a blood meal that the mosquito gets from its host, and then they sort of evade the immune system of the mosquito, and then they're able to be replicated and then transmitted to the next victim. So, certain viruses have been able to evolve those features over time, and many of them, get selected against, So, yeah, it's just we don't really understand exactly how that works, but we know it happens, and so there are many viruses that are transmissible by mosquitoes.
I guess that's one thing that's really interesting, is where a virus like a coronavirus is going to affect its host, as well as seek out other hosts through a variety of vectors and transmission options. But you said those viruses don't actually affect the mosquitoes. Is that correct?
Yeah. So they're when you do fitness experiments on infected mosquitoes versus non-infected mosquitoes, there's not there's not a significant difference. So there's no real obvious negative consequence of being infected by the virus on the mosquito, right? So that enables the virus to sort of to persist and to be spread, right? Because if it were to negatively affect the host, or the vector, I mean, let's say, when the virus gets in the mosquito, it kills the mosquito. Well, that wouldn't be an ideal scenario for the virus, right? Because then the virus would quickly get selected against, because it would just kill all of the vectors. So there has to be this balance, right? Where it's in order for the virus to spread, it doesn't want to negatively affect the vector.
So that reminds me of the difference between, among many differences, but the difference between, as we described it, SARS, or SARS, the disease that came from SARS-CoV-1, and how much higher the fatality rate was from that than SARS-CoV-2, and as we've described it, COVID-19, where so many of the cases were asymptomatic, and while those people had lower viral loads, from as far as we can tell, it still enables the virus to spread further, to transmit further, because it's not killing the hosts as often. Am I misunderstanding that?
No, you're exactly right. If the virus is going to kill its host, then it's less likely to be spread as far. So SARS-CoV-2, like you said, there was many asymptomatic cases, and that contributed to the wide scale spread, right? That's still ongoing, and it's in some ways it's the perfect storm, right? You have a virus which can be lethal, but in most cases it's not, and it can go undetected and enable its rapid spread through air droplets. I mean, it's the perfect storm for a pandemic.
And it's interesting, and this is probably a different conversation. I mean, I've had it quite a few times, but we don't need to go down this route. But what made this more deadly to certain groups, and turned out to be many of the most marginalized groups in America, were the pre-existing cardiorespiratory and cardiopulmonary conditions that already existed, which were one layer of what makes COVID-19 more deadly to many of those groups, because of the way it operates once it's in your body, versus healthy white young people, for example, who certainly have been affected, but not nearly as fatally as many of those groups. But then also, again, like you said, because it is able to transmit so much more, I guess, silently or subtly, you see it transmitting so much more effectively in these places where, again, many of those same groups are living in multi-generational households or working in meat factories or whatever it may be. People weren't dropping dead immediately, so it was able to keep passing through them pretty quickly.
Right. That's exactly the case. It's super unfortunate.
So I want to understand a little bit about this specific mosquito that you mentioned, and I'm going to definitely mispronounce its name. Aedes aegypti. Can you do a better job of that for me?
Yeah, Aedes aegypti.
Aedes aegypti. Oh, damn it, so close. So, Doc, what is it, and why is it so much more dangerous versus other mosquitoes? Or maybe I'm misunderstanding that, but can you talk a little bit about what it is and what it does and how it lives and why it's so different?
Right. I mean, Aedes aegypti is an invasive mosquito originating from Africa, and it's spread throughout, the Americas during the slave trade. And it's present throughout the United States and Central and South America. It transmits a number of different viruses. So it transmits dengue, Zika, yellow fever, chikungunya virus, for example. And it also is a species that has evolved to sort of prefer to live in human, where humans live, and it prefers to breed in these small little containers. So even a bottle cap from a soda bottle, for example, if it was full of water from rain, aegypti would actually lay its eggs in that, and that's so it can propagate in very small pools of water, and it also prefers to bite during the day, and it can hide in our households, and it's an extremely intelligent species, and also its bites. When it bites you, you don't really feel anything. It doesn't hurt at all. So it's just really efficient at at sort of dwelling with humans and transmitting pathogens. So it's one of the ones we need to really worry about here in the United States, because it's now become relatively abundant.
That's super helpful and more or less terrifying. I mean, it sounds like every one of those beats was something specifically engineered to be super effective, including the fact that you don't really notice when it bites you, which unlike, for example, a snake bite, where in some cases you have a limited amount of time to get the venom out, for example, or take an antidote. I imagine there's not really anything like that when you can't tell, and when it's biting all day versus dusk, which is, I think, how a lot of folks imagine mosquitoes to be prime hunting hours.
Exactly right. And they're also incredibly intelligent as well. There's been studies where they've actually done sort of conditioning, and they found that these mosquitoes are able to learn, and adapt relatively quickly. So, like when the mosquito lands on you to bite, if you swat it away with your hand, it'll learn from that, and it won't. It'll learn that that's something that they should avoid, and next time it'll sort of adapt and bite in a different spot. And so it's really fascinating, actually, that they're how intelligent they actually are.
I'm glad that you find it fascinating. For me, it's just like, oh my God, that's wild. I mean, we humans do a poor enough job extending the term intelligence to a huge variety of species on this planet that deserve it. But that is pretty wild for an organism that we, I guess, laymen, especially myself, don't consider that complex. That's pretty incredible. So I know, and again, I mentioned I've spent most of the past 12 years in Los Angeles. I'm kind of back to the East Coast now, but one of the bragging rights of Southern California, besides it used to be mildly sunny and warm, which is not so much the case anymore either, and I guess kind of goes part and parcel with this, we didn't used to have a lot of bugs, and now we do. Can you talk about this mosquito showing up in California and Southern California, and what that has done, how much it's spread, and I guess how, this climate crisis and how it's getting so much hotter in a lot of these places, why are they becoming breeding grounds for this serial killer of a mosquito?
Right. Yeah. I mean, this mosquito prefers warmer climates. So as temperatures warm through global warming, it's actually expanding its habitable range. And back to California, it invaded California in 2012. So it was first found, in parts of Southern California in 2012, and since then it's basically spread throughout the entire state. It's found in pretty much all counties, and I mean, I live in San Diego, and in my backyard, I find them, right around during the day when I'm working in the yard, or even at dusk, I find them and I catch them, and I have a little microscope in my office, and I bring them in just to confirm that they're what I think they are, and they are what I think they are. And so it's a pretty big problem. I think we really need new tools to address this.
For our West Coast listeners, how much have they spread since 2012? Is this a fairly sporadic, I guess, weak yield, or have they really infiltrated the place?
I mean,
because I think a lot of people that have been there for a long time don't really realize the extent of it, unless I'm misunderstanding it, which is more or less how my day goes.
No, I mean, they've spread throughout the entire state, and fortunately in California, there's really good vector control programs throughout the state, and in San Diego we have a really good program too. And prior to their, this vector control program, like many, actually will trap mosquitoes and bring them back to their labs and sort of speciate them, so they know sort of what species are present, in the population. And what's happening now is this species is actually becoming the dominant species that's found in these traps, right? So that's telling you that it's actually it's not just sporadically here. It's kind of invaded, and it's here to stay, and it's becoming the dominant vector.
Good times. Okay. Well, that's helpful to know to, again, set the table for folks to, again, further understand that this is not just an issue that's in Africa or otherwise, that it's not just a Zika issue in Florida. It is everywhere, and especially in California, which is, as we can tell, getting quite a bit hotter. Just to pivot a little bit, Omar, in I think late 2019, mid 2019, and I alluded to this offline, we had our first conversation about mosquitoes with a woman named Dr. Natalie Koffler, and she's a molecular biologist, I believe. She's teaching at Harvard Medical School, and she founded Editing Nature, and they're basically again, as I understand it, a working group trying to explore and push folks around the world to conduct serious ethical investigations. So not just with the microscope, not to minimize that, but really, taking the sort of liberal arts view of before we just genetically modify a bunch of male mosquitoes or what have you and let them loose in the wild, asking those questions of should we? And one analogy I recall her using, discussing the power to build, for example, gene drives into mosquito populations was CRISPR, and how Dr. Jennifer Doudna, who started CRISPR, really tried to very early on recognize the power that was there and tried to consider in her own lab and push the nascent CRISPR community to incorporate ethics from the top to make it a more transparent space for everyone. And I imagine, and there have obviously been a few hiccups here and there, but that's probably a big part of the reason why CRISPR hasn't just been ripped loose everywhere so far. But along the way, and even before that conversation we had, I recall, there are genetically modified mosquitoes have been released in Indonesia to try and combat dengue. And I know, I believe recently Oxitec released a few 100,000 engineered mosquitoes in the Florida Keys this year. I saw one report, and again, please correct me if I'm wrong, that Aedes aegypti is only about 4% of the mosquito population in the Keys, but it is responsible for all of the mosquito-transmitted disease, which kind of tracks with what you were just saying about being a super predator. But local folks were really against the release. So, basically framing it as, look, it's not super appealing to have a science experiment released in your backyard to see if it's going to continue to kill you or not. So I wonder if we can talk about ethics along this stuff. How much are ethics part of your lab's work? How much do you consider that when we talk about, this thing is happening, we need new tools?
Yes, those are great questions. And ethics is extremely important in the work that we do. And we think about it every single day. And I've written articles, with social scientists and ethicists related to gene drives and genetic control of mosquitoes in the past. And so we think about it all the time. And just going back to your point with the Florida Keys trial with the Oxitec mosquitoes, you're right. There was a lot of resistance there, and people were afraid, and they didn't want to be guinea pigs, and they thought that why are they doing this in my backyard? And so there was that sentiment, but I think a lot of that stems from just fear of something going wrong, and really that has to do with it being such a new technology, right? It's
sure.
It is relatively new. Using genetically modified organisms to control populations is not something that is done regularly, right? And so there is going to be that fear initially when you have a new technology, but Oxitec has done its diligence and it's trialed this technology in many locations with great success, and in a lot of ways it's safer than what we're currently using. If you go back and you just type in Zika in Florida on Google, you're going to find images of airplanes like just spraying neighborhoods, and you just see the spray coming out of the back of the airplane, which is insecticides, right? What is the consequence of that, right?
100%.
And when you have a technology where you're actually using the species to control itself, right? It's a really nice technology because male mosquitoes know how to find females, right? You just release them, they go out, they find them, they mate with them, and that will control the population. And in a lot of ways, that's far safer than what's currently being done. And I think it's just not well understood, and it's still considered a new approach in technology, and that people are just afraid of it in general.
Sure, and I think that context is essential, right? Because it's not as if this is our first attempt at trying to stave off these infections and this spread and these disease vectors. We have been trying, and again, these are intelligent species. Not to mention the viruses themselves, they're going to evolve and adapt, like bacteria has been doing to all of our antibiotics. This isn't our first attempt, and while of course we should be incredibly ethical and stop and ask, how are we proceeding? Who are we affecting? Why are we doing this? Are there any other options? Have we thought about the best way to test it and release it and promote it? It's important to always put it up against what's already out there. And I mean, pesticides are a nightmare, right? I mean, the number of flagrant existing issues, for example, we're losing bees everywhere. So it's important, I feel like, to come back to first principles on these things, right? Which is gene drives and technologies like this to like you said, the males are going to go find the females. If we can do the work and they can control their own populations, great. Pesticides have been a nightmare. They've helped in some ways, but obviously created a whole host of other issues, all the way from, again, bees down to our soil doesn't really work as well anymore. Like you said, images of planes dropping pesticides during Zika. Coming back to these fundamental building blocks, which is these issues and these animals have been there forever, but now one of the biggest issues is this overheating planet. I'm curious if you at all integrate that sort of multidisciplinary thinking into your work, which is, hey guys, also we need to deal with climate change because California is getting way, way hotter and it's becoming a breeding ground for this thing I'm working on. It's not just heat death as an issue. It's not just crops. It's also becoming a much bigger disease vector for this specific problem that has killed, like you said, more humans than anything else in history. Do you guys think about climate change in your work at all? I'm curious.
Yeah, that's great. We do think about climate change, but mostly in respect to how it's changing, like vector populations and sort of the movement of those species and along with that you get potentially more disease transmission. I mean, we think about it in that respect, not so much of can we develop a technology in our lab that's going to tackle climate change. We're not specifically working on that that goal to stop climate change, but we're working on sort of trying to develop tools that can combat sort of these problems that are going to continue to become bigger problems as climate change continues. So most of our focus right now is on mosquitoes and going back to your question about ethics and how we incorporate ethics into our work, we've thought a lot about it. And really, one of the big concerns right now with gene drive is that, gene drive has the potential to sort of modify entire species, right? And the question is, what is a modification that you're gonna use? And so there's one use of gene drive is called population modification, where the goal is to spread a effector into a population that can provide a refractoriness to a pathogen. So, for example, malaria resistance, right? So if you have a gene that can prevent the mosquito from transmitting malaria, then the goal would be to spread that gene throughout the mosquito population, and then once it reaches fixation, the mosquitoes will no longer be able to transmit malaria. That's kind of the goal of it, right? But the problem is that you're with current gene drive designs, we don't really understand enough about these effectors to sort of allow us to release mosquitoes that sort of encode these effectors into populations and allow them to spread everywhere, right? And uncontrollably. We can't. We want to do it in a controlled way where we can sort of test these effectors, and if they don't work or if something unintended happens, then we can remove that gene drive from the environment. And so I think a lot of the ethics has to do with, okay, well, how can we how can we release something that we can't control afterwards? And then who gives you permission? Who has a say in that, right? So if you release it in one location and it can pretty much go everywhere, is it okay for just to get regulatory approval and public acceptance in just that one location, the initial release side, or do you need to get it everywhere, right? And so these are just some of the ethical concerns that are kind of on the table that people are actively discussing at the moment. And so, in our work, what we've been doing is actually sort of redesigning genetic control systems to be effective but controllable. So we've designed ways to use gene drives that allow only controlled spread in a single population, and then we've also gone back and designed completely combinable genetic control systems that don't use gene drives that can also be used to eliminate populations of insects and animals. So I think we definitely have listened and we agree that the concerns are valid, and so maybe we're not ready to sort of unleash something we can't control at this point in time, which is understandable. And it doesn't mean that there are not other ways to design these systems to make them controllable, to enable safe testing, and also to potentially reduce disease transmission and save lives. And that's kind of what we're working on.
Sure, and it's not black and white, right? We can't just say, look, this thing is killing X number of people a day, like, let's push this thing out. But at the same time, it is helpful to have that comparison, which is, we have to take some shots at this because it is, like you said, killed billions of people throughout history and continues to do so. I'm curious, what are some of the biggest, most, I guess, frequent obstacles that you and your lab run into in understanding these issues and developing these new mechanisms? Are they technical? Are they ethical? Are they funding? Are they regulatory?
I would say all of the above,
Perfect.
Yeah. I mean, you have to get funding to do the work, which sometimes can be challenging. And then, you want to develop tools and systems that will be used, right? We don't want to spend all of our time engineering something in the lab that's just going to sit in our lab. We want to make sure that what we develop is what people need and want and what regulatories will allow us to use. And so I think, you have to kind of participate in all of these discussions in order to understand the complexities of what's happening in the world and what's really needed and wanted at this time. I think with mosquitoes, I think with gene drive, for example, I don't think we're ready to release something that we can't control from everything that I've participated in and heard from both regulators, ethicists, social scientists. And, if I didn't participate in those discussions, I probably wouldn't realize that. Right. And so I think, it's really important to be involved in all those discussions and when you realize something is potentially not feasible, right? Even though you can build something doesn't mean it's something we can ever use, right? But when you realize that, I think it's important to go back to the drawing board and rethink, how can we redesign this to fit the need? And I think that's where we do a lot of our thinking in our group.
Well, I think that's pretty specific and obviously probably immensely more helpful than just crop dusting everything with pesticides, which a lot of drawbacks. Doc, so our goal is to provide, like I mentioned to you, these specific action steps our listeners can take to get involved for themselves, for the greater system, to support your mission with, as we say, sort of their voice and their dollar. And it can seem a little, I think, probably distant for folks to affect the implementation of mosquito gene drives around the world, right? Unless they're already working on it or part of the regulatory system or policy making, and our audience has all of those folks in it for sure. But at the same time, I imagine there are effective things that they can do. So let's try. Let's start with their voice. What are the sort of actionable but specific questions that the rest of us should be asking of our representatives? Like I know you mentioned, the groups, and I apologize, I forget the nomenclature for the groups that will capture the mosquitoes locally and test them and things like that. where can people have an effect? Because obviously mosquitoes biting you and making you sick is a pretty hyper-local problem.
Right. I think there's a lot of things that people can do, right, to sort of prevent themselves from, being bitten by mosquitoes, for example. They could use repellents and things like that. And they can speak up too. I mean, they could, if they find that there's mosquitoes in their yard that, were not a problem previously, they can call their local vector control program. And there's one in almost every state, and speak up and let them know, like, hey, look, we now have a mosquito problem that wasn't here prior, and we want solutions to this, right? And right now the best solutions are really mostly insecticide based, but hopefully in a matter of time we will have more of these genetic control systems being trialed and potentially used in the environment, and when that happens, I think we may end up with more control of these mosquitoes. But I think it's also important, going back to the Oxitec example where people were very afraid of the technology and things like that. I think it's also important for people to educate themselves on what the problem is and how is it presently controlled, and what are the risks, right? And how have these technologies been validated and used in the past. And I think with the Oxitec example, people would have found that it's a very safe technology. Honestly, it's not something that is predicted to cause any harms, and it's been well vetted by the EPA. They've done a lot of testing to determine whether there is any adverse effects that could happen in the environment, and they're continuing to do that, right? They're not just releasing it and hoping everything happens. I mean, they're actually ongoing experiments that are being done that will validate whether it's being transmitted to other species and causing effects in other species and things like that. I mean, those are ongoing, and you need to continue to do that while you perform the trial, because you can't, a lot of that information you can't get from a laboratory experiment. You have to do sort of a more area-wide experiment, which is what's happening here.
Is there a good source you can recommend? And if you need to do some thinking on it, we can just put in the show notes that where people can educate themselves on, again, not just the specific experience in specific experiments in specific localities, but more how these things work to get a better understanding just in general, so that they are prepared when they're either advocating for them or finding out that it's happening locally.
Yeah, I mean, I think CDC, has information on their website for, related to diseases. And then, in terms of specific genetic control systems, I think, for the Oxitec example, Oxitec has a website that's dedicated to that can be found online that will provide information about the trial and about the how the system works, and even their approvals with the EPA and things like that can all be found there. And I feel like it's better for people to sort of educate themselves before they make a decision on something, right? They can't just automatically decide, okay, well, it's genetically engineered, I'm against it, right? I think they need to go in and really think about it a little bit and compare to what's being used presently, and make a decision after that, But as we see more of these systems, used in the environment, we generate more data on the safety, right? And so far, they seem to be safer than anything that's been used. And so I think it's really important to get that message out.
Absolutely, I think that makes sense, and we'll find those links and we'll put them in the show notes for everybody so that they're accessible. Well, Doc, I want to thank you for all your time here today. I don't want to keep you. Obviously, you're working on some pretty important stuff out there. So we just have a last few questions we ask everybody, if that's all right, and then we'll get you out of here.
Perfect. Yeah, sounds great.
Awesome. Doc, when was the first time in your life when you participated in something or realized you had the power of change or the power to do something meaningful, either alone or with a crowd or a partner, whatever it might be?
Something meaningful.
Sure.
Well, I'll just keep it, mosquito focused, because that's what this is about.
Sure.
So I will say that, while I was in college, I I was getting a bachelor's, master's in biotechnology at the University of Nevada, Reno, and that program required all the students to sort of work in labs. And I had the opportunity to work as a vector control intern at the Washoe County Vector Control District in Reno, Nevada. And it was there where I sort of learned all about mosquitoes, right? I learned how they transmit pathogens. I had my own sentinel chicken flocks where, there's 10 flocks that were located all around town, and I would go collect blood from them every week and test them for transmitted pathogens like West Nile or St. Louis encephalitis. I had my own mosquito fish colony where I would go out and put mosquito fish in ponds to sort of consume mosquito larvae. And I also participated in helicopter aerial applications of insecticides. And I think it was this experience, which I did for 4 summers, really, I learned comprehensively of how vector control is done. I did it firsthand, and how, in my opinion, how expensive and inefficient it is. Right? I mean, we were using the most advanced insecticides and literally helicopters to apply them, and mosquitoes would still, I would still find mosquitoes every week, right? And so, and that was in a very developed area, Reno, Nevada. And so imagine how it looks in rural parts of Africa, for example, where you don't have that type of infrastructure or control. And so, that's where I realized, that something better needs to be developed, right? It wasn't just me reading a textbook or anything like that. It was actually firsthand experience of applying insecticides and surveying mosquitoes and all that. And I just, it was like it hit me hard. Like, okay, well, I need to stay in school. I need to get a PhD. I need to develop something better. And so after that program, the biotechnology program, I stayed on and got a PhD in cell and molecular biology. And I focused on insects. I worked with flies, developmental biology of flies. And then I went on to a postdoc at Caltech for 6 years. And it was there where I really focused on genetic control systems. And I participated in seminars and I learned from the best, right? And that's where a lot of these developments have sort of, that's where I've been inspired to sort of develop these different genetic control systems.
That's awesome. Well, that's obviously a pretty crucial point in time for you, watching it and taking part in something that is at that time the best we've got, but, looking around and going, this can't be it. This can't be our best shot at taking care of these things. I feel like we're going to look back in, a certain period of time, and we already obviously do this. I mean, we look now, back prior to penicillin and you look at the difference between how casualties were treated in World War I versus World War II. And obviously we still do it, but for a long time, the best answer was to just cut someone's leg off to stop infection. And that is thankfully not the case anymore. Or, now we're starting to very, very, very slowly and strategically starting to move on from things like chemotherapy, which have been our best option in a lot of cases versus cancer, but can be just as brutal as the cancer itself. And hopefully, done ethically and strategically and considered well by folks like yourself, something like gene drives can be far more useful and have far less friendly fire, as they say, than something like insecticides and pesticides to try to, control a very significant, very wide-reaching problem.
Yep, that's exactly right.
Doc, who is someone in your life that has positively impacted your work in the past 6 months?
The past 6 months have been challenging, to be honest with you.
I'm sure.
I've been on Zoom and isolated. I mean, okay, so I would say, these last 6 months, I have been working remotely, exclusively, and so all of the work that has been done in my lab has been done by the people that I employ, which are the postdocs, the grad students, the students, which have worked tremendously hard during such uncertain times. And so, I would say all of the impact of my work is handed off to them because they are the ones actually doing the work. I'm just sort of the director and sort of provide advice and thinking. So I would say the people that have impacted my work in the last 6 months are my direct the people that work in my lab.
That's awesome. Well, I can't imagine how frustrating and difficult your work has been over the past year. So we're thankful that you and all those folks in your lab have persevered. Certainly. Quick pivot, Doc. Amid all this, what has your self-care been like? How have you taken care of yourself? Because I've talked to any number of scientists over the past year, and it seems like finding that thing has been pretty essential to keeping your head on straight.
Right. I think initially, it was really hard, like having to leave the lab and not even have a lab for a period of time because everything got shut down. That was really challenging. And I think I just learned how to adapt, right? So initially Zoom really sucked, right? I hated it. And, I still prefer in-person meetings, but I think over the last year, over a year and a half almost, I've gotten used to it. I've learned how to, use Zoom effectively and manage remotely, which, I had never done prior. And so I can give you an example of we have our weekly lab meeting, and before it was in a conference room, coffee, bagels, fruit, and it was enjoyable. We'd go around table and we would have ideas, and it was a lively discussion, right? And that switched to just a Zoom meeting, and one of the ways I've sort of dealt with it is every week I go to the beach. So I go down to La Jolla Shores. I put on my headphones and I walk. I do my Zoom meeting on my phone, and I just walk up and down the beach for 2 hours, and that helps me sort of get my mind off what's going on, and also to get some exercise. So I'm not just sitting in my office all day at home.
Sure.
So I think those are some of the things I've done to sort of deal with it. But I'm really looking forward to just getting back to normal at some point.
I think we all feel that way, Doc. Well, I'm glad you've found ways to cope, certainly. Last one. What is a book you've read this year in all of that free time that has opened your mind to maybe a topic you hadn't considered or an angle you hadn't considered before, or it's actually changed your thinking in some way?
Yeah. I've actually, I say over the last 2 months, I've read 2 books. One of them was The Codebreaker by Walter Isaacson, and the other was is Editing Humanity by Kevin Davies. And I'm only halfway through Editing Humanity. But, The Codebreaker was a good one for me because, we work with CRISPR, and just hearing about all the heroes of CRISPR and sort of their story and how it progressed into what it is today was really inspiring. And it actually has inspired us to sort of do a little bit of searching. We have some new projects in our lab where we're actually mining prokaryotic genomes for new types of bacterial control systems that could be potentially manipulated for different purposes. And so we've actually, through bioinformatics, we've identified a number of things that are really interesting, and I think it's taking us into different directions. So I think that was all inspired from reading these books, and it's just that's my answer.
That's pretty great. Isaacson, boy, he did a great job with that one, like he has in so many of the previous ones. It's pretty incredible, that story. Listen, just want to say thank you. Where, if anywhere, can our listeners follow you and your lab online or in the news?
Yeah, I have a Twitter account. You can find me on Twitter. I have a website at akbarilab.com. You can find me on there. There's also a link on there for donating. If anybody wants to donate to our research, you can do it there.
Oh, cool.
And we're regularly on the news, so you might find us on the news as well. And I think those are the best places to reach me. And my email address is also located on our website, so you can reach me directly if you want to.
Awesome. Well, listen, I can't thank you enough for your time today and all the work you're doing for a problem that is obviously going to become much more prevalent in the US. Hopefully we can contain some of these larger outbreaks, but we're trying to do a better job here of talking about things like adaptation when it comes to the climate crisis and such. And these are obviously all interdisciplinary or multidisciplinary, however you want to phrase it, systemic issues. And mosquitoes have been around for a while, as are so many of the viruses they carry, but hopefully the work of folks like yourself can keep our hand out of the frying pan for a little while longer. So thank you for all the thought you put into it, and also obviously all the work you do under the microscope.
Perfect. Thank you so much. I really enjoyed this interview, and looking forward to hearing it when it airs.
Awesome. Thanks to our incredible guest today, and thanks to all of you for tuning in. We hope this episode has made your commute or awesome workout or dishwashing or fucking dog walking late at night that much more pleasant. As a reminder, please subscribe to our free email newsletter at importantnotimportant.com. It is all the news most vital to our survival as a species.
And you can follow us all over the internet. You can find us on Twitter at importantnotimp.
Just
so weird. Also on Facebook and Instagram at Important Not Important. Pinterest and Tumblr, the same thing. So check us out, follow us, share us, like us. You know the deal. And please subscribe to our show wherever you listen to things like this. And if you're really fucking awesome, rate us on Apple Podcasts. Keep the lights on. Thanks.
Please.
And you can find the show notes from today right in your little podcast player and at our website, importantnotimportant.com.
Thanks to the very awesome Tim Blaine for our jammin' music, to all of you for listening, and finally, most importantly, to our moms for making us. Have a great day.
Thanks, guys.